Hello, Dr. Mike here for Introduction to Computer Forensics. This is log analysis, which at the time of this recording is topic 14. And using the current textbook at this recording time, it is chapter 4 logs. There's actually a chapter also in the Linux section about log files. So this week's topic is, of course, log analysis. There is a NetLab which actually goes into really good detail about both Windows and Linux log. So Windows event logs, Linux logs. The chapter itself talks about the event log for Windows in chapter 4. I'm not going to go into any details about Windows logs. You're actually going to have a really good introduction to that and look at some tools for analyzing this, as well as Linux logs too. I'll say this for Windows logs. These are typically sort of a binary log, and there are parsers, as you can see here, and these are application event logs. And you can view them, but a lot of times you're going to use some sort of log viewer to help you view these. But you can also view them just regularly. In this case, there's an event dump.pl file using NetLab. So there are definitely log analysis tools, both open source and as well as closed source. Of course, things like Ncase is going to have probably event viewers help you parse these logs. And Windows logs, again, are binary. Normally, Linux logs are text. There can be some exceptions to that. But again, you'll find tools to help you also view Linux logs. What I will put out is this. Logs are essential to forensics. This is really one of the, again, cornerstones to find evidence. Now the problem with logs is there's a lot of noise. So how do you find that signal in the noise? Where do you find that specific record? So log parsing is going to be a very important thing. So I'm not going to go into, again, Windows logs or specifically Linux system logs here, but I'll talk about logs from other areas. In this case, let's look at Apache. So the Apache access log. Let's talk about logs, server logs, because really when we're looking at evidence, you might be going outside of the suspect system. So let's just use this here for example. We have our suspect system here. We know the IP address, both internal and external, from the router modem. So again, we gathered information during initial examination. We know what it was connected to. We have, of course, the image of the hard drive forensically saved. And from there, we can see there's activity in the web logs. So looking at the browser logs, for example, previous topic. But browser logs might expose us to maybe some system logs too, to activity that's outside the system. So we want to talk about log files on servers. And this is where we're going to look at Apache, for example. And let's talk about logging itself. So let's look at a web server here, Apache Web Server. And something to keep in mind is when you maybe, in this case, not really a warrant, but probably just a subpoena for the logs, which is usually acceptable for an IP. Maybe this is a web service, maybe this is a website, or this is an email or whatever. This is something that we need to look into. It could be a search site, and we subpoena those logs. And again, we got to keep in mind that those subpoenaed logs do fall under best evidence. Again, we can't get the actual web server taken out, that log server taken out and put onto a shelf, right? So an official copy of those logs does fall under best evidence rule. Is a certified copy gathered with a subpoena and still handled as original evidence. So you'll probably use a copy of those logs. You don't want to ever touch the copies that are given. This is going to depend too, also. If you're coming from a forensics side, from the corporate side, you might just use the raw logs themselves, copy them over and look at them and see how you were hacked, for example. In any case, there's some activity here against this web server. Let's talk about logging, for example. So you do our logs on servers typically, but usually when it comes to corporate, commercial websites, you have more than one web server. Usually you maybe have 3 to 5, using an odd number for load balancing. So web server 1, 2, 3, 4, and 5. Now, it's not uncommon at all in large-scale operations. It will keep logs locally, but uses some example called like rsyslog, remote syslogging. I'm sure Windows has something on this too. Is we don't actually keep a full copy of the logs here. We actually put those off to a logging server. We'll put that as ls here. Because logs are parsed a lot, not just for forensics use. They're parsed to see activity, errors, the health of the system. Information gets parsed from logs for DevOps. Information usually goes to like DevOps boards where you have, charts and graphs. And if you're into a big DevOps center, they have these things projected on the walls, CPU, memory use, network, loading and all that stuff. Information about the health of the network and these servers is, up to date. And this is usually done on a log server because you don't want to parse logs on the actual web server, right? We want that CPU memory used for, receiving and taking care of web traffic. So it's not uncommon to have logs, cut a copy locally as well as cut a copy to a log server. So very common. So if you have to subpoena a web server for some activity, just be in mind that there actually might be a combined log, or there could be a secondary log here on the server. If you're coming from the corporate side where maybe one of these was hacked, this is also why you do remote logging too, is you kill that server that was hacked. Most time if an intruder does get in, they will try to block their log activity. They might delete logs. But again, a copy has already been sent to a remote logging server. So this is going to be your basically your evidence, help you figure out how you got hacked. So again, we look at it coming from internal, log server. You might use that to figure out how something happened, how you were hacked. Or if you come from a criminal side, we see there's activity from the suspect system, and we think there's some logging activity. They did some searching. Maybe they deleted their history here, but we might be able to find it out here. So keep that in mind there. And so I'm going to bring it up about how corporate logging, industrial, commercial size logging works. So you'll see logging servers for that. So in case, let's look at a log. So again, the topic itself and the NetLab is going to walk you through Linux systems, as well as, and we saw here in Chapter 4, Windows event logs. Again, very, very, very important logging to look at. But let's talk about, again, other ways you might look at logs. So again, you might find yourself having to parse logs yourself. You might build, if it's a subpoena to a company, maybe a web search company, they might have the technology to actually parse the logs for you since they already have that in place. They might be able to help you with that. But just keep in mind that understanding different log formats might be important. So you might find yourself with different parsers out there. It could be online tools, it could be built-in binary tools, it could be, I'll show you an example, it could be a simple Python code you might use to parse something. So understand log formats. In this case, this is a nice little site here. Shows an example of an Apache log itself. User address, the authentication, date, time, the offset, the action, the return code, and so on. So having this stuff bookmarked or available for the technology used. So it's important to know what version of Apache is being used in this case. What version of the web service is being used. It could be FTP, it could be email, and so on. It's going to help you find up and look up the standards that are used for logging for that service. Because again, we're going to have what we saw here. This is an example access log for Apache here. You have a lot of noise. Log parsing is about dealing with a lot of noise. And so this is an example. This is a sample I got from a sample website from Forensics Files. Again, it's pretty big. 16.4 megabytes. This is actually pretty small. These files get very, very large. Luckily, they're text most of the time. Even if they're binary, they can be compressed down, which is nice, and then be transported and uncompressed. But keep in mind, if I'm going to walk through a week's worth of web logs, that can be a lot of processing. So you don't want to assign this to a weak system. You might want to have a parsing system in place or something that's got some CPU and some memory backbone to help run processing. So again, you can see here, this is just a a simple log. And you can see here, if I run this, I basically am just using a simple Python here. I'm importing the log file, and I have some regex. Now, regular expressions, very common use for parsing. You can see host, space, identity, user, time. So I wouldn't found this online, but you might find yourself with a library of different regex, regular expression parsing, used for certain types of log files. And you might want to keep this. It's handy, but that way you can customize parsing for certain information. But now if I open this log and I run it, you can see it parses through it, it grabs each line, prints it out. Using my regex, I could actually parse it out into different chunks and get areas I want. Maybe I want just the IP address and the get, what was, or the request itself. So, and then I can do is, in this case, let's just use this example here. Comment that out. Let's say I know the IP address of our host. Or again, let's go back to that diagram. I know that our suspect's IP address, based on the date time, based on their router log, and based on the information from their IP address from maybe from the registry, or from the information from their IP config, if it's a Linux system. Again, this was gathered during evidence gathering, so I have this. I know it's a 68.116.149. This is the external IP address, at least the base of it, let's say. And maybe it changes throughout the day. Typically, again, check with your ISP. Your router log will show if it changed IP address. Let's say I want to parse with this. So I'm using a simple starts with, and voila, pooh, I do have 2 hits here. So I have a 68.106. I can see they went to this lc.gov, and they got search Yahoo page here, and here's they use Mozilla. So, and then maybe that's their browser. So that matches the browser logs for their browser history. And maybe this search information here is what I want. Maybe they search for something, how to hide a body. you see how many of those 48 hours, someone searches how to hide a body. It's a pretty bad idea to search for how to hide a body, because it's not going to do you any good for protecting your evidence. But again, this might help us find that link in the chain. So again, this log came from a web server log. It does show a search was made, and I can tie this IP address back, and this this browser string itself here, it matches the browser information for the web history log, as well as the IP address from the router log and their ISP. So again, we're sort of linking together a search that was made, even though maybe the local search history was deleted. Maybe they ran in local mode. They still can find a search page out here. So that's all. Just be aware that when it comes to parsing logs, understand the logging servers are used for a lot of services. Again, maybe the search is to look for, maybe I'm looking for IP address. Maybe I'm looking for a certain string. Maybe it's a string for a hack. Maybe it's like a cross-site scripting event or SQL injection type string. So again, I can use this to figure out when and where someone tried to do a SQL injection on what page for our website. So again, we look at this from 2 sides. Maybe from the cybersecurity forensic side, or again, maybe in this case, this example, I'm looking from a criminal forensics. I want to find information for this IP address where they search. So again, you might need to gather a lot of logs. Maybe they can help you. Maybe if it's a Google or a Microsoft or someone, maybe they have a way to extract logs for only that IP address. In any case, make sure you have information about the subpoena, and you have the ability to go back and verify and say, yes, this log file did come from a certified copy from Google. Google certifies it, or Microsoft does. Again, it does fall under the best evidence rule, but you can't get that server yanked out and put into a safe. So, in any case, you might find yourself having a library of different log parsing. Maybe with Python, maybe using specific tools. As usual, always keep track of everything you use. Keep track of the code that was used. Keep track if it's a tool, what version, and the results of that tool for output for the final report. Okay, this might not be exact evidence, but it's trace evidence to help connect and maybe help write the story, the timeline for the case. In any case, that's it. I just want to go over that sort of sidebar there of log parsing. Again, you will definitely look at Linux system and Windows event logs within the NetLab. So that wraps up topic 14. Hope this is helpful. Have a good day. Thanks.